In this video, we'll talk about other ways to find Taylor series that don't involve writing out all the derivatives of this function. So, like we saw before, we found the series for sine of x by taking derivatives and seeing what the pattern was and using that to then write out the series. That worked for that function, but that was pretty long and tedious. There are a lot of other ways you can get to Taylor series without using that fact, and that's what we're going to talk about here. So, one of the main ways is by composing with a known series. So we know series for 1 over 1 minus x, for sine of x, for cosine of x, and for e to the x. These are all things we know. So we can use these series to then write out more complicated ones like we did for the power series expansions previously. So something like e to the x to the fourth, I know how to write that Taylor series because that's just the e to the x power series where I plug in x to the fourth for the x. So this is the sum from n equals 0 to infinity of x to the fourth to the n over n factorial. Same idea like we had for power series. We can also multiply and divide known series by powers of x. So, for instance, I could look at the series for x squared over 1 minus x, and this would give me x squared times the sum from 0 to infinity of x to the n. I can just put that now inside. Sum from n equals 0 to infinity of x to the n plus 2 will give me the power series for that function as well, which is also then the Taylor series because we know this is the same thing. We can also, because we know we can differentiate and integrate things term by term, use derivatives to tell us what these things should be. So the way there is something like if you're doing an arctan, which we've done previously, we now know that that power series we got is now the Taylor series for this function. Right, this is integral of 1 over 1 plus x squared dx, and that I can write as a power series, which is then a Taylor series because it converges. We can also get series by multiplying two partial series. So this is the idea of multiplying a power series from before, but for instance, you get the first couple terms, say of the series e to the x times sine of x, by multiplying them out. You're not going to be able to find the entire series this way because it's hard and complicated, but you could write out the first couple terms and see what you get. So for instance, this would be something like 1 plus x squared over 2 times x minus x cubed over 6, x to the fifth over 120, and so on, which means this series starts with an x for the first term. For x squared, I can get that by just x times x. For x cubed, I can get that by the x squared here times this x, or this 1 times x cubed. They're going to be subtracted, so I will get x cubed over 3, and it continues like that. As an example of this, let's find the Maclaurin series for f equals x sine of x squared. This is going to combine our multiplying by x and composing with the known series rules. So we know the series for sine of x is this one here. To get the series for sine of x squared, I just plug in x squared for x, and then multiply by one more x to get the final thing that I should get. This will become x to the 4n plus 2, and then plus one more gives me 4n plus 3. You could also do this result by noticing that x sine of x squared is negative 1/2 the derivative of cosine of x squared. Because if I differentiate cosine of x squared, I get a 2x negative sine of x. That cancels the minus sign, cancels the 2, and I get my answer there. You could also start this way, and you get to the same series as well once you do the manipulation to get there. So these are some other ways you can find Taylor series. The base way is always just take derivatives, figure out the pattern, and use that to write the series. But if you've got a known series involved there already, you can use manipulation with that series to then determine what this new Taylor series should look like for your new function, assuming it looks enough like a series you already know.